Alright, today we're doing solving, adding, and subtracting equations, but with rational numbers, okay? So it's very similar to what we did with just solving basic equations, except for now we're doing everything with rational numbers. And if you don't remember, rational numbers are not whole numbers, it's fractions and decimals, okay? So some of the steps are very similar to what we've already done, such as draw railroad tracks on either side of the equal sign. I know some of you don't like to do that, but it really does help separate things. And then you circle the variable and anything attached to it. Don't forget the sign. And remember, when I always say circle the variable and anything attached to it, this is called the term. I know I've reminded you of that before, but you're circling a term. So in this case, you're going to circle the x. Step 3 is to get the variable by itself by using inverse or opposite operations. Okay? And you have to make sure that you do it to both sides. Whatever you do to one side, you have to do to the other. So in this case, we have a plus 2/3. Okay, the plus is what we're going to do away with. So we're going to subtract 2/3. So we're going to subtract 2/3. And then those cancel and leave you with x equals. Then you have 1/2 minus 1/2 minus 2/3, and that equals negative 1/6. So your answer is going to be negative 1/6. And this is to solve for the variable. Okay, and this is to leave the sign. Okay, what I'm saying is you're not changing your sign, you're changing the operation. And so that's one problem I kept getting on the other just solving one-step equations, was that you see like a -6 divided by something and you think, oh, it's adding or subtracting, and no, it's just a negative. Okay, you're doing an opposite operation. And so here, if this is a negative 1/6, like your answer, leave it. It's negative 1/6. Okay? Here, you're not changing the 2/3, you're subtracting the 2/3. Okay? You're not changing the signs, you're changing the operation. That's really important. And that's actually a really huge distinction, that we're changing the operation. And the final thing is to check your solution. Okay, so let's check our solution. So now we have negative 1/6, plug it back in, plus 2/3. And what does that equal? Let's see. Negative 1/6 plus 2/3. It equals positive 1/2. And so we did that correctly. Okay, now, I know one thing I have a hard time with. Let me grab this for you so you can see it. Maybe I can't find it. It's kind of a little cheat sheet to help you recognize what operation is taking place. Okay, most of you won't need it, but some of you, I'm going to give it to you, and it's just to help you know, like, hey, this is an addition problem, so you need to do a subtraction. Okay, and sometimes it'll be a multiplication or a division problem, and you have to know which operation is taking place, because that's a big deal, because we're doing an opposite operation. We're not changing the sign, okay, unless it calls for it. Now let's look at our together problems. Okay, number 1, we do our railroad tracks. Circle your variable. You have a plus, so we're going to subtract 2.8. subtract 2.8. Those cancel and leave you with an n equals, we have a negative 0.3 plus a negative 2.8, negative 3.1. And that is our answer. And then you can check it by just plugging it back in. Negative 3.1 plus 12.8. $9.7. Oh. So see? Oh, so that means I did something wrong. That's why we check solutions. What did I do wrong? Brilliant. What did I do wrong? Okay, this was a 12. This was a 12.8. Okay, so it's negative 12.8 plus negative 0.3. So this should have been 13.1. That makes so much more sense. I was just going too fast. Okay, so that's why we check solutions, because I can say those don't equal each other. So now let's try my other one. Negative 13.1 plus 12.8. Negative 13.1 plus 12.8, which equals negative 0.3. And that matches. So that's not a solution, and this is. Oh, my darlings, that is why we check solutions. Brilliant. Brilliant. Okay, railroad tracks. Circle your variable. Okay, remember, if there is no sign, it's being added. So these are being added, so you need to subtract 4 2/5. Subtract 4 2/5. Those cancel. And you're left with m equals. And here you have negative 3.5. Second fraction gives you a mixed number. Negative 3 1/2 minus second fraction 4 2/5. Negative 79 over 10. Now let's check that. Negative 79 over 10 plus 4 2/5 equals what? So you can actually just take that and do plus 4 2/5, and it gives us negative 7/2, which is, convert to a mixed number, negative 3.5. 3 1/2, which is a solution. Okay. Next, number 3. You have your railroad tracks. Circle your variable. Now this is a great one. It's minus a negative. So 2 negatives make a positive. So it's actually a p plus 19 over 6. And so the opposite of plus is to subtract 19 over 6. Subtract 19 over 6. Those cancel, give you a 0, and you're left with p equals negative 2 1/2, second fraction, negative 2 1/2, minus 19 over 6, which is negative 17 over 3. And if you noticed, I'm leaving all of these as mixed numbers, or as improper fractions. Sorry, I'm not turning them into mixed numbers. A mixed number is a number with a fraction. You could do that here easily. You could say 3 goes into 17 5 times, so it would be negative 5 2/3. You could do that. I just think it's tedious, which means it's one more step that we really don't need to do. You can just leave it as negative 7 thirds, and I'm not going to mark that wrong. Okay, and then we check it by plugging it back in. Negative 17 thirds. Negative 17 thirds plus 19 over 6. And that should give us, and then change that, second, convert, and that will change it to a negative 2.5. So it matches. And that works. Okay? Honestly, this was a perfect example of why we check our answers. Sometimes it's a simple mistake like I forgot the 1, but it completely changed everything. And so it's really important that we recognize that. Okay? Now you have 3 practice problems that I want you to do, check, and get completely done. Okay?